In this circle, we have two chords, AB and CD, that are perpendicular to each other. The lengths of some parts of these lines are given. We need to find the radius of the circle. This problem comes from a math contest in the 1970s. Pause the video and try it for yourself before we get into it. We are going to use an approach called coordinate geometry to solve this cleanly. First, we place a circle on the coordinate graph where the two chords meet at the origin, the point 0, 0. We do not know where the center of the circle is yet, so we call its coordinates P, Q. Now we label the points where the chords touch the circle. Point A is at -2, 0. Point B is at 6, 0. And point D is at 0, -3. Next, we bring in the equation of a circle, which gives us the distance from any point on the circle to the center. For point A, that equation looks like this. -2 minus p squared plus q squared equals r squared. R is the radius. That is what we are solving for. For point B, the equation is the same structure. Now we have two equations. We subtract one from the other. This cancels out a lot of the complicated pieces, and we find that p equals 2. With p equal to 2, we plug it back in and get a cleaner equation. 4 squared plus q squared equals r squared. Now we use point D in the same formula to get a third equation. We simplify using p equals 2, subtract again, and we find that q equals 0.5. Finally, with p equal to 2 and q equal to 0.5, we can go ahead and plug both values into the original circle equation. After the arithmetic, we get the radius r equals the square root of 65 over 2, which is approximately 4.03. And that is the radius of the circle.